Hello everyone, this video is titled Topic Recap on Energy Profiles. We will recap also what an exothermic and an endothermic reaction is, and then we will demonstrate and represent those on what we call an energy profile. So first of all, like I said, a recap on what exothermic and endothermic reactions are, which you should already be happy with before you start viewing this video. So an exothermic reaction is a reaction which transfers energy from the reacting chemicals to their surroundings. So it is a chemical reaction that will release energy, and that energy will go into the surroundings. And this is an example here. Basically, making any chemical bond is an exothermic process. So when two particles join and bond together, heat is given out, and that heat, the energy is given out in the form of heat. Okay, so it's an exothermic process. So two particles joining together, bonding together like so. Okay, that reaction there gives out energy. It's an exothermic process. So we would say making chemical bonds is an exothermic process because the process releases energy. Then we have an endothermic reaction where the energy is transferred from the surroundings but into the reaction. So exothermic is reaction to surroundings. Endothermic is surroundings to reaction. Okay, now breaking chemical bonds is an endothermic process. Okay, so if you thought of let's just say again, having two magnets together, they're opposite poles and you've got a magnetic attraction between them. Okay, to break those two magnets apart, you'd have to apply some force, wouldn't you? You'd have to pull the magnets apart, they'd come apart, you'd break the magnetic bond or force between them. Okay, you would use energy to break those two magnets apart, and atoms and particles are exactly the same. To break these particles apart requires energy. Energy is taken in mainly in the form of heat. Okay, and then we have our two separate particles, and because energy is taken in, we call it an endothermic process. So breaking chemical bonds is an endothermic process because it takes energy into the reaction. Okay, now we're going to place these two phrases, or represent these two phrases, on what we call an energy or reaction profile. Okay, so what is a reaction profile? A reaction profile will always have a set of axes like so. So it will always have energy on your y-axis, okay, and progress of a reaction or time on the x-axis. Okay, so you will always have that as like a standard. Now you heard me refer to it there as an energy profile. If you're doing any kind of old exam questions, they'll call it an energy profile. The current GCSE specs refer to it as a reaction profile because the profile, the graph, is detailing what happens to the energy within a reaction. Okay, now in a reaction profile, I'm just going to do a really basic diagram here, and then I'm going to talk about endo and exo separately. But what you do is we actually place the reactants of a reaction, should I say, and the products on the graph by a line. Okay, so we have the reactants have a certain amount of energy on the profile, and the products will be shown to have a certain amount of energy on the profile. Okay, obviously in terms of time, products have come after the reactants because the reactants are turning into products. So a lot of the time with these graphs, students forget to link back to the x and the y axes. So this line here shows that in this example, the reactants have a higher energy than the products. The products are actually later in terms of time than the reactants, and they will always go in that order: reactants, products, reactants, products. You then see the product line or the reactant line changing depending on what is happening. Okay, so first of all, we're going to look at an exothermic reaction. So this diagram here is a little bit more of a detailed version on what I've just shown you. Now here they put heat energy. Really, I'm just going to cross out heat energy. Okay, We shouldn't always talk about the energy being heat. Let's just call it energy, okay? So we've still got our reaction profile here, energy and progress of the reaction. Now you can see my product line and you can see my reactant line, okay? In this example, in an exothermic reaction, we have the reactants at a higher energy level than the products, okay? And if you think back to what an exothermic reaction is, the exothermic reactions release energy. The energy is lost into the surroundings. So reactants are here. The reaction happens, it loses energy, so the products end up with less energy, okay? And we connect the two lines by this hump. Okay, so we had our two lines originally on our previous slide, but they're now connected by this hump, and that's characteristic of an a reaction profile. Okay, and it's just literally an up and down line, okay, connecting the reactants to the products. Now the difference in energy here, like I just described, is called the overall energy change, and we label it in kilojoules per mole. Okay, and overall here you can see the products have less chemical energy than the reactants do, okay, because the reactants turn to products, okay, and actually I'll write this up here. So reactants turn always into products, okay. However, in an exothermic reaction, energy is given out. Okay, so the reaction loses energy to the surrounding, which is why the products have a lower amount of energy than what the reactants do. Now, the last arrow you can see here is called the activation energy. Now, activation energy comes up in the rates of reaction topic, where you look at catalyst altering the activation energy. Temperature is also linked to activation energy. The activation energy is simply the energy that it takes for the reaction to start. Okay, and we represent, I guess you can imagine the top of the hump being the reaction. So reactants, reaction, products. The top of that hump is where the reaction is happening, and the energy it takes from the reactants to the reaction actually happening is called the activation energy. Now, this topic, again, like all I always say, are all quite tricky, and it's definitely something difficult to understand if you haven't been formally taught it and you're just watching this video for the first time. Realistically, in terms of GCSE questions, you can gain a lot of marks from just learning what that profile looks like by heart. Okay, you don't really, in terms of to actually draw this, you don't really need to understand the chemistry. You just learn what an reaction profile looks like, and you can just learn what an endo profile looks like. Okay, but in terms of wanting to understand what is actually happening here, you must always refer back to the energy and the progress of the reaction. So the reactants here have got X amount of energy. The reaction happens and we reach our activation energy, but because it is an exothermic reaction, energy is lost to the surroundings, so energy decreases by the time we end up with our products. The difference in energy between the two is called the overall energy change. Now we're going to do exactly the same thing, but we're going to look at an endothermic reaction. So an endothermic reaction, we are still going from reactants into products. So you can see there on the graph, the reactants are always listed before the products, okay? However, you have got energy coming into the reaction because it's an endothermic reaction. So we've got reactants here, and then we've got our products. Now, rather than we go up again, so both profiles have the going up, okay, to reach our activation energy. Now the graph does decrease in energy, but we only decrease to the products which are above the reactants. So the products have got X amount of energy here, reactants have only got energy down here, and it's because throughout the process of an endothermic reaction, we actually have energy come in. Okay, so we still have our overall energy change, which is the difference between the reactant line and the product line. We still have our activation energy, which is the energy difference between the top of the profile and the reactants line. Okay, you actually, again, this profile here says heat energy. You can cross out the heat part. you really should just write energy. But that is a profile, so you can see how between the endo and the exo, all you need to do, the graph shape is very similar, but the reactants either have more energy than the products or less. So like I said, in terms of gaining marks in a GCSE question, they can ask you various things. They can ask you to draw the whole thing from scratch. They could draw a profile for you and ask you if it's endo or exo. Other things, they could draw a profile for you and you have to label it. It comes up as a like a couple of mark answers, so a couple of marks question. It also comes up as a multiple choice question as well. So you must learn these profiles. In terms of gaining marks, realistically, you can gain quite a few marks from just learning these two profiles by heart. Okay, so this is another video. I really recommend taking it back to the beginning and watching it again. It is quite a tricky topic if you're watching it for the first time, but ultimately we can pick up quite a few marks for just learning the shapes of both of the profiles.